Hi there, this is Mr. Deiulis again, and I'll be talking to you about vectors a bit more. Last time we had talked about tip-to-tail vector addition and parallelogram method vector addition. Now we're going to look at it from a coordinate plane. So if I have a coordinate plane and I put a vector here, and let's say that this vector has a length of 5 and it is measured from the x-axis, the angle theta, let's say, is 53 degrees. And we always want to measure our angles going from the positive x-axis going counterclockwise. Always want to try and do that whenever possible, and if it's not already set up that way, it's pretty often easy to change that around. So if I, for some reason, had that angle measured here, then perhaps it would be easier to change it to this 53-degree angle measured going counterclockwise from the positive x-axis. Now with that, we want to break this vector down into its parts. So we're going to show its x and y components. So you can see that essentially what I've done is I've kind of taken tip-to-tail vector addition and done it in reverse. Rather than starting with the two component vectors and making the resultant, I've sort of taken what's kind of a resultant here and broken it down into x and y components. So here I have whatever vector, and here it is in the x and y components. Well, now I need to find the length of those x and y components. In fact, let me give this a name. I'm just going to say that this is vector A. So this is vector A in the x, and this is, again, vector A in the y. And so what are these values equal to? So we need some trig to find that out. And you'll perhaps, if you can look back at the initial video I had done on some math prerequisites of trig, but we have SOHCAHTOA. As long as we measure off of the x-axis going counterclockwise, what I'm about to show you will always hold true. That's why it's so nice to do it this way. So let's start with the y component. I'm going to use sine. So the sine of angle theta is equal to the opposite over the hypotenuse. And since it's the opposite over the hypotenuse, well, the opposite is actually the vector A in the y direction divided by, well, vector A along its path. If I want to find the vector A in the y direction, then I simply need to multiply each side by vector A along its path. So sine of angle theta times A is equal to A in the y direction. That in turn gives me the sine of, in fact, let me take these things and move them up a little bit. There we go. So the sine of the 53 degrees times the 5 is going to give me whatever the value is in the y direction. And that will give me a value of 4. It's a 4-5 triangle. I really like those because it makes my life easy. So this is 4. And if I do the same thing with cosine, I'm going to say that the cosine of angle theta is going to be equal to, well, that's the adjacent divided by the hypotenuse. So the adjacent is going to be the x direction divided by A. So that means that cosine of angle theta times A is equal to the adjacent side, which is the x direction. And again, putting in our values, the cosine of 53 degrees times 5, that will give us 3. There we go. So I've broken it down into its x and y directions. And that's all you need to do for that one vector. Okay. So as long as I measure off of the x-axis going counterclockwise, all I need to do is know that the vector in the x direction, I'm going to use cosine, and the vector component in the y direction, I'm going to use sine. Multiply it by the hypotenuse, and I will get that component. Keep that in mind. It's going to get a little bit different, but as long as you can remember that, it can stay a little bit easy. Let's add in another vector. Let's do vector B. Vector B, let's make orange. And let's put them, where are we going to put them? Let's put them over here. Now, what if I told you that this vector had a value of, I'm going to make up some actual arbitrary numbers, a value of 4, and its angle, let's say that I'm going to measure the angle off of here. Let's make that 20 degrees, going clockwise off of the x-axis. Well, as I said, your life gets much easier if you measure off of the x-axis going counterclockwise. So what is that angle going counterclockwise? That would be 180 minus 20, so that would give us an angle of 160 degrees. If I were to break this one down into its x and y components, I can go ahead and draw that out. So here's the x, and here's the y. But yet I've drawn an angle outside of that triangle. But that's okay. Don't worry about that. Stick with me here. What I want to do is I want to find what is the resultant of these two vectors. So let me go ahead and take this one and put it to the tip of that. Remember, we have vector A and vector B. The resultant of these two is going to be the vector addition of the two of them. Let me put the resultant in red. And that's going to be my resultant right there. That is the addition of those two vectors. That's the end goal that I have, is to add vector A and what is vector B in orange. Okay, so I'm bringing down vector B, which is a value of 4 units at an angle of 20 degrees clockwise from the x-axis, otherwise known as 160 degrees counterclockwise. Let's break that one down into its x and y components. So vector B in the x direction and also vector B in the y direction will have values. Well, let's see. The x direction is going to be equal to the cosine of the angle as long as you measure the angle going counterclockwise from the x-axis, 160 degrees, times the hypotenuse, which is 4. Vector B in the y direction will be equal to, well, sine, as long as it's always measured from the x-axis, 160 degrees, times 4, which is the hypotenuse, and we have our values for each one. Let's find out what those are. All right, so putting those values into your calculator. By the way, remember to always be in degree mode, not radians, because if you take calculus, you're going to wind up putting that calculator into radian mode for calculus, but you have to switch it right back to degree mode for physics. So in the x direction, we have a value of 3.76, and notice that that's going to be in the negative direction. Actually, you will get a you should get a negative value. You'll get a negative value on your calculator, which is the nice thing about putting in that 160 degrees. And then for the y direction, we'll have a positive value of 1.37. Now, if you notice, you can actually find the length of those vectors by using the 20 degrees. This one down here, the x direction, you could use the cosine of 20 degrees times 4, and that would give you 3.76. But not the negative. When you put in the 160 degrees, the calculator knows that it's assuming that you are starting from the positive x direction going counterclockwise. That's the way it is designed, is to measure off of that x-axis going counterclockwise. So that is the nice thing about putting in the 160 degrees, is it will give you the negative value. It will give you the magnitude and the direction. The calculator is designed to give you the vector under those assumptions. Now, what I want to do is make an x, y data table. And with that x, y data table, I'm going to have vector A, I'm going to have vector B, and my resultant. And I'm just doing the two vectors. I could do this with 20 vectors if I wanted to, although that would be a nightmare. With vector A, I have the x component. Well, that was a positive 3. There's the y component. That was a positive 4. I had vector B in the x direction. It was a negative 3.76. And in the y direction, it was a positive. This was positive as well. Don't need to always put positive, but just to make that expression. 1.37. And these are arbitrary units. I could write in my meters per second or meters if that was what it was. Now I'm going to just vector add these together in each of their components. So the x, well, let's see, 3 plus a negative 3.76 will give me a negative 0.76 units. And in the y direction, 4 plus 1.37 will give me a 5.37. Almost done. This is the part, though, that a lot of people have trouble with. I now need to make, essentially, a new triangle. So what the heck, let me just make a new coordinate plane, and I'm going to make a new vector. That new vector, it's going to have an x value. Sorry, let me go back up. It's going to have an x value of negative 0.76, so it's going to go to the left 0.76, and then it's going to go up from there a value of 5.37. So this is the 5.37, and this is the negative 0.76, and it's going to make a resultant going from the very beginning to the very end. Let's make that in red again. Very beginning to the very end. And it is going to have some length to it. Well, since this is a right triangle here, we can find the hypotenuse of that triangle. So we're going to use Pythagorean theorem to find that length. And then we can also find this angle here, or if you prefer, we could wind up finding this angle here and adding 90 to it. So there's several methods there. But we essentially want to usually go from the positive x-axis going counterclockwise. All right, so let's work on that. All right, so using the Pythagorean theorem, we're going to solve here. So a squared plus b squared equals c squared. And the a, we'll just say it's 5.37 squared plus, and we can use the absolute value of this number. We're just trying to find the magnitude. So 0.76 squared, and then take the square root of it to find c. And that's going to give us a value of 5.423 and some odd numbers, but I'm not too worried about significant figures. That's something we can talk about another time. So let's just kind of end it there. 5.42 is plenty good enough. That is the magnitude of my resultant, but not the direction. All right, well, how about if we did this? What if I move this over here and move this one up here? You recognize, again, that's the same x and y components. If I look at the triangle in this way, let me find this angle in here, and then I will add to it 90 degrees to find my angle off of the x-axis. So if this up here is the 0.76, again, I'm not worried about the negative at this point because I'm going to find the angle for the direction. And this side here is 5.37. What is that angle? So I have the opposite side and the adjacent side. Well, again, with my SOHCAHTOA, I have the opposite and adjacent, and I want to find the angle. So that means that the tangent of angle theta is equal to the opposite, which in this case is 0.76, divided by the adjacent side, which in this case is the 5.37, I now want to find the angle. So if I take the inverse tangent of each side, I will get this, that the inverse tangent of 0.76 divided by 5.37 gives me the angle theta. And let's go ahead and do that solution. All right, that'll give us an angle of 8.055 degrees for that angle right in here, and we can add in 9 degrees to that to give that our value from the x-axis. So that would give us 98.055 degrees, and really that additional stuff isn't really all that necessary. It should be 0.055, but that's what we have to do. So we have to add the vectors together to get resultants, a magnitude and a direction, so that way it's a true vector in the end. If we recap, got that vector, I can throw it up there. And if you notice, it's right on top of the other one. They're the same vector, just about. So I have vector A, I have vector B. The addition of those two vectors will then create a resultant. I have to break down the two vectors into their x and y components, and put those values. It's helpful to put them into an XY data table, especially when I'm trying to look at what you're doing. That's terribly helpful. Make sure you don't mix up the x's and the y's. That tends to happen from time to time. Make sure you keep track of them being positive and negative values, right? So this one here was a negative value. When you come up with the new x and y values of the resultant, remember, the next step is to make a new triangle. So take those and turn them into a new vector where you have some length you can determine from the Pythagorean theorem, and an angle. You use some pretty straightforward trig to find the angle. Try and find that angle from the x-axis going counterclockwise. All right, so that is vector addition, and hopefully that is helpful. All right, have a good one.